All right, so Cody wants to do number 26 and 27 in 1.2, which is recommended. And we might notice that there's really only one problem here because I'm pretty confident that draw a parallelogram got sorted. Parallelogram? Check. Full credit. Yeah, so these were supposed to be one problem that said draw a parallelogram with two sides V and W. Okay, so here's my parallelogram. I know you all are super blown away by my parallelogramming skills right now, huh? It's okay. You can hold your applause. I'm learning to use this friggin' program and I'm really proud of myself. So you all just go ahead and be amazed. All right, everybody happy with my parallelogram? Oh shit, what's wrong with my parallelogram? Thanks, Joe. That is in fact a rectangle.
You actually don't get full credit for 26, Joe.
Well, not now. I'm so disappointed in myself. You guys have no idea. That's
pretty much still a rectangle.
It's pretty much still a rectangle. How about we just go like this? Oh, no, I changed the side length. We're done. That's it. Full credit result.
He's right. You got a 0 on this problem.
Harsh, bro. Come on, a rectangle's a parallelogram. I just happened to pick vectors that were perpendicular to one another. What? All right. Okay. So now finally having my picture, I am supposed to show that the squared diagonal lengths. Oh, where are the diagonal lengths? Let's see. So one of the diagonals is this one. And the other diagonal is, this one. You guys with me on that?
How are your lines like locking into place? Or is that just me?
I don't know. I have no idea. Yeah, don't ask. Don't ask questions I don't know the answer to. All right, what is this vector right here? That red one?
V minus W.
Yeah, it's either V minus W or W minus V. I have it pointed this way. So let's see. So whatever the hell it is, if I add it to V, I get W, right? So I get V plus questiony vector is W vector. So that reads like it's probably W minus V to me. You guys all on board with that? Oh, crap. And I needed V minus W. So I should point that the other way. Pretty good with that? Ah! I'm not sure I'm going to be able to get that out of there, to be completely honest. Oh, maybe. Oh, that was part of it. Hey, look at that. Okay, so I got my V minus W vector here. This other one. What's that one?
V plus W.
Yeah, that one's V plus W. Okay. So I'm supposed to show that these squared diagonal lengths add to the sum of the squared side lengths. Okay, so the squared diagonal lengths What tool do I have that gives me a squared length? You guys got a tool for this?
Isn't it the dot, or it's the dot product with itself?
Yeah, the dot product with itself is the magnitude squared, right? So anytime you see a magnitude squared in any of these problems, your brain should probably jump to calculating a dot product. You guys all good with that thought? Even if it doesn't work out, it's a good place to start. So the place I'm going to start is I'm going to say, all right, the magnitude of v plus w squared plus the magnitude of v minus w squared is going to be the same thing as v plus w dotted with v plus w. Oops, sorry, that's the wrong notation. Forgot what class I'm teaching. It is the vector v plus w dotted with the vector v plus w. How about that? Is that notation we've seen?
No, I don't see the. Yeah, there it is. Okay, now I recognize it. It was confusing me before.
Thanks, Grayson. All right, and then we're adding v minus w dotted with v minus w. Okay, and then we're going to use some properties of dot products to multiply these out. You guys with me on that? So I'm going to get v dotted with v plus w. That's a w. Plus w dotted with v plus w. Basically, I'm just distributing here. You guys all on board with that? Okay, so I'm basically multiplying things out. Pretty good with that? You can check that these properties work. These are really like this step is properties of dot products. There's a theorem in the book that summarizes all the dot product properties. Okay, and then we want to do that same thing, distributing through the parentheses again. And so we're going to get v dotted with, v dotted with v plus v dotted with w plus w dotted with v plus w dotted with w plus v dotted with v minus v dotted with w. I may have just pulled a fast one on you there. Everybody with me on that? I pulled a minus sign out. It's a little weird. It's one of the properties of dot products that you can pull scalars out of them. You guys all remember that rule? Maybe? Okay, good deal. Same, right? Properties of dot products. And now, do you guys see anything going on here?
There's a bunch of like terms that you can combine.
Yeah, I feel like there's some like terms. Like I'm seeing this thing here. That's w dotted with v. And then over here, I'm seeing a minus w dotted with v. Great. Those cancel. Why do they cancel? Good answer, no one in particular. It's because they're scalars and they have opposite signs. Okay. And then my minus v dotted with w cancels with the v dotted with w. And then in the end here, I am left with a magnitude of v squared. That's v dot v, right? And then I have a magnitude of w squared. That's w dotted with w. Oh, and then I have another one of each of those. You guys all on board with that? And so now using some properties of scalars, I can say that this is 2 the magnitude of v squared plus 2 the magnitude of w squared. Everybody on board?
Yes, sir.
Have I lost you all in any way in particular? Okay. Let the punchline of this one be see this as this. Pretty good?
Yeah.
Okay, cool. All right, other homework questions? Other
Did we-
judgments about my parallelograms, Joe?
I have one more question for 2.1.